So let's have a look at the output file for our CFA. I have opened it here with a different software so we can more easily annotate it. As always, the first thing you see here is a repeat of the input instructions. And then if you scroll down, you will see potentially a bunch of warnings and maybe even errors. Every time you see these are related to your input instructions. In our case, it looks like they are all related to the fact that our input lines were too long. However, if you have a look at what was truncated, you will notice that they are all comments, annotations, so it looks like this is okay and we can proceed. So let's keep scrolling. Underneath you get the summary of analyses. Why don't you have a look and try to think about what each of these numbers here represent, and also about what these two lines mean. Right, so we can see we only had one group and 783 people in our sample. We had 12 dependent variables because remember, the items are actually considered dependent variables here. So you get them listed here and you see they were listed as either binary or ordered categorical. We didn't have any actual predictors. However, we did have 3 continuous latent variables: self-kindness, common humanity, and isolation. Notice also that the estimator used was WLSMB, weighted least squares with robust means and variances. And that's obviously because we had categorical dependent variables in our study. Now let's scroll down further to see what else it is we get here. So I'm going to skip over this section here, just noting in passing that the number of missing data patterns is 1. So basically this means that we had no missing data, and therefore all the numbers underneath in these matrices here will be 1, which means that we had 100% of the sample with data on every pair of variables. So let's skip through this and move on. We now get this section here, univariate proportions and counts for categorical variables. What do you think these numbers mean? Take for example these numbers here that refer to the first item on the self-kindness scale. Right, so the first 2 numbers here refer to proportions, and these 2 numbers here refer to counts. So I would say this number means that 50.4% of our sample chose category 1 of response on the item SK1. And in actual numbers, this means 395 people selected that category of response. Now, a small but important point here. If SK1 had actually 3 categories in your questionnaire, but people only used 2 of them, it would still show up like this in the output. So MPlus will identify how many categories were used, but not necessarily how many categories you thought you might have. So if you had a Likert scale with 7 categories, but only 5 of them were used, MPlus will list 5 categories here. Now, if we scroll down a little bit further, we get our favorite line of the entire output, the model estimation terminated normally. And underneath, we get the section called Model Fit Information. So let me put this neatly on one page and ask you, what do you think? Did the model fit the data well or not? Okay, let's go through it together quickly. So the chi-square was not significant, and that's excellent. The RMSEA is below 0.06, and even the upper bound value of its confidence interval is below 0.06. So that's great. The CFI and TLI are both above 0.95 and the SRMR is below 0.08. So it looks like we had excellent fit based on all of our indicators. Just as a quick reminder, if the chi-square is significant, it's not necessarily a problem. The chi-square is extremely sensitive to sample size, so it will most likely be significant if you have a large sample. But it's still good to note it and to put it down in your paper and to have a look at it before you look at the other indicators of fit, and to remember that all indicators of fit are actually calculated using information from the actual chi-square. Now let's scroll down further and have a look at the results. So we have the unstandardized solution here, and there are a few things to note. So first of all, these estimates here are the factor loadings, and that's because they come in the by statements. Notice here that the first loading for each of the subscales is 1, and it is also fixed. You know that it is fixed because the p-value is 999, which is just a convention. This is known as the marker indicator approach or the reference indicator approach, and it is the default for M+. It is important to use this in order to give a metric to your factor. There is, however, an alternative approach whereby you free that loading and fix the variance of the factor to be 1 instead. So in sum, the default for M+ is to fix the loading of the first item to be 1, and therefore pass the metric of that item onto the factor. Now, why don't you take a moment and try to figure out the rest of these numbers on this page? See how far you can get on your own, and then we'll do it together. Right, so let's take them in turn. So the first bit here is a bunch of correlations between the factors. You can see that they are all not significant. Now, we ultimately decided against putting in correlations, but you can see that M+ did them anyway, so this is another M+ default. Now, it might be a good idea to take them out. There is no need to keep such correlations in if they are not significant and we didn't also make them a major hypothesis in our study. Remember that in SEM, we favor more parsimonious models that do not have redundant paths. So, how would we make sure that we get rid of these correlations and override the default? Do you remember what kind of statement we would need to put in? Alright, so let's say we take the first one. If we wanted that one to not exist, what we would do is we would say hum with kind at 0, like so. And then we would do the same for the other two correlations. So basically you take the correlation and you fix the coefficient to be 0. Okay, let's have a look at this other section, thresholds. So let's see what these things here actually represent. You see that for each item, you get one of these parameters. So for example, for the item SK1, you get this SK1 and then the $sign at 1. So by definition, the thresholds refer to the level of trait you must have in order to switch your response from one category to the next. In this example, SK1 refers to the factor of self-kindness, and we had two categories of response, category 1 and category 2. And the threshold defines the level of self-kindness you must have in order to have selected category 2 instead of category 1. So you see, for example, that for SK2, the threshold is actually lower. Perhaps even with lower levels of self-kindness, you might have still selected category 2. But for SK3, the threshold is quite high, so you must have pretty high levels of self-kindness to have selected category 2 of response on SK3. Now, if you had items with more than 2 categories, let's say you had an item with 3 categories, then you would obviously have 2 thresholds. So if SK1 had 3 categories, then in the output you would have 2 variables there. You always have a number of thresholds that is equal to the total number of categories minus 1. Alright, let's move on and have a think about this section. What do you think the numbers here represent? Okay, so let's see. Variances in general refer to the spread of responses or the spread of scores. And here, they refer to the spread of scores on the factors. So they refer to the extent to which people vary from one another in terms of self-kindness, common humanity, and isolation. Now you notice that all of these variances are significant. And this means we did not have a homogeneous sample along these dimensions, but instead we had a heterogeneous sample. If you have a homogeneous sample, it's not a problem in itself. But if it's heterogeneous, like is the case here, then it's excellent news, because you can use it further to answer questions such as what predicts or what explains these variances in levels of self-kindness or common humanity or isolation. So, in fact, if you want to use these factors in further regressions, for example as part of an actual structural equation model, but you don't get any significant results, perhaps you will want to take a step back and think, is it possible that I had a homogeneous sample to begin with? That's because regressions try to explain variability in scores in one thing as a function of variability in scores in another thing. So it relates variances between constructs to each other. But if you don't have significant variance, then perhaps there's nothing to explain. Alright, so let's move on and keep scrolling. Underneath we have the standardized results, and here we chose the STD standardization because all of our items were categorical. So now we get to see the standardized results, and they are standardized only by the variance of the factors. That makes a lot of sense because the factors are continuous variables, and so they do have a variance, whereas the items are categorical. In fact, they are binary, so they don't actually have a variance in that sense. A small thing to notice here is that in the standardized results, the variances of the factors are fixed to be 1. Okay, so let's scroll down further and see what else it is we get. We are now almost at the end. So we get this section titled R-square. Do you remember what the R-square represents? What do you think that first number there means? Right, so the R-square, which is depicted here, refers to the amount of variance in the items that is accounted for by the factor. The amount of variance in the outcome explained by a predictor. Now notice that this is significant for all of the items. However, you still have something left over, and this is depicted here by the residual variance. And if you are to add together these two numbers, for example for the first item, you see that they add up to 1, the entire variance of the item. Indeed, whenever you have an outcome, its variance in responses is always split into that proportion that is explained by the predictors and the leftover, the residual. Now, for factor analysis, you would probably want to think about it in a slightly different way. Building the factor relies on pulling together the joint variation in the items. So each item has some bit of its variance which is in common with the other items. This is known as the joint variance, and we make the assumption that it is caused by that factor. But for each item, scores might also fluctuate in a way that is unique to that item. So we have something left over, some proportion of the variance which is unique to each item, which we list here as the residual. Some people refer to this as error, so they make the assumption that that leftover variance is explained by other factors, one per item, so some kind of source of unique variance exists, which is latent. Other people would just call it the residual variance, and other people would call it uniqueness. I quite like the version where it's termed uniqueness. That's because it doesn't make the assumption that the source of that variance is due to random noise. It could be due to other things that make sense, including other substantive factors. Alright, so we've reached the end of the output, and the last bit of information we get here are the model modification indices that we requested, but we notice here that there are no modification indices above the minimum value. Quite often, when you get model modification indices here, they would refer to correlating residual variances of multiple of your items. We will also get to do some of that when we do a full structural equation model. But for now, this is it. If we wanted to finish this study, we would probably want to go ahead and fix these correlations to be 0 so that we no longer have redundant paths, and then we would check our model fit again. So let's go ahead and do that in the input file, and then consider other avenues for building this model, specifically with regard to the existence of a second-order factor.